We're getting very rapid heating in comparison to geological scales, like much more rapid than anything we observe in any of the ice cores or any of the historic indicators like oxygen isotopes for temperature in the history of Earth. We're very good at observation in science. We're not particularly good at prediction. If we're able to model all the scenarios, if we're able to create a better model than the current, the AR6 one, get to a really granular scale and start looking at ecosystems and start looking at as many interactions as we can. If you can get a range of solutions from that using quantum computing, it means that intervention becomes safer.
So imagine that you have the technology of Iron Man, where he used the artificial intelligence to build the technology, and you add this to the capabilities of Doctor Strange, where he speaks about the quantum things and he speaks about the predictions and the simulation of things. So imagine these two powers, which you will have now, to provide for them the right tool to the science. So what will be the result? It will be huge.
The carbon dioxide reduction curves have gone from lines like that to more and more steep lines of we need to reduce more rapidly than we would have needed to if we'd started doing that 20 years ago. We need to then use technology to get us back to something that's safe, which is why it is the United Nations that has been leading this, and why the withdrawal of the US from the Paris Agreement is particularly problematic, because that then breaks that international agreement. Even with the success of the UAE consensus, and that was an amazing point where the whole world was working together at that, and it really took a lot of effort within the UAE to reach that point.
So what you mean, for example, is, say, because it'll be all instantaneous, if something happens in Tahiti, then something in Ireland will be able to help it or counterbalance it
Immediately.
This
is what I'm saying, the entanglement and the new physics. It's a pure new physics. How come they will be entanglement and they are far? What we can see now, we just see the view from one player in the game. Once the quantum computer is there, you will see the whole field, all the players' views, and the team that play against you, and where the position of the goalkeeper. So you will be able to score goals. This is the power of it.
Gentlemen, thank you very much for joining us today. It's a pleasure to have you here, renowned experts. If you'd like to introduce yourself.
Mostafa Kabel, I'm a Chief Technology Officer for a technology and distribution provider, Cambridge and MIT alumni, and a Master for Artificial Intelligence and more related to technology perspective.
I'm Steve Wilkinson. I'm Director of Research and Graduate Studies at the University of Wollongong in Dubai. I'm a geologist and a geotechnical engineer by training, and I research sustainability, applied sustainability.
Amazing. Gentlemen, thank you very much for joining us. Stephen, I'm going to start off with yourself, and in regards to geoengineering. So, it's probably the easiest question. What is geoengineering?
Geoengineering is it's ways in which we try to control our environment at the relatively large scale. So you could say at the smaller scale, as we start in the UAE looking at enhancing rainfall, as we send up these missions to put salt into the clouds to make more rain fall on the country, we are in some way changing our environment. So that's what geoengineering is, but we're now thinking with the issues of global warming and climate change about, can we control our environment to the extent where we can control that warming?
Okay.
And you could say also that all of the fossil fuels that we've been burning, putting carbon dioxide into the atmosphere, is also geoengineering.
Right.
We're changing the environment through our actions.
Yeah.
But we want to do it in a more controlled way. And there's a few different aspects to geoengineering that we commonly look at. One is trying to mitigate the issue, so removing the carbon dioxide from the atmosphere in some way. And there's a few different ways of doing that, and we can pump air through a big fan and freeze it in some way to create liquid carbon dioxide and then store that deep below ground. That's a direct air capture.
Okay.
Or we can do something like hit a load of rocks, break them down, and then as they break down, they start absorbing carbon dioxide through a chemical reaction. And that happens naturally. And we've had, as India crashed into Asia, the Himalayas went up, that enhanced rainfall that caused the breakdown of those rocks and then transported a load of carbon dioxide into the oceans via the rivers. So that's a natural process, but we can do enhanced weathering as a human process. The other approach is, well, we could say that sunlight is the problem. We're getting too much heat from sunlight, so we also have ways of reflecting sunlight, which goes from the technological, let's put incredibly large mirrors in space, and then the sun hits the mirror and doesn't go to the earth.
Okay.
Or we can change the brightness of clouds so that they will reflect the sun and act like mirrors.
The brightness of clouds?
Yep.
I've never heard of... So the brighter cloud, then...
the more reflectant it is, and so that will reflect the sunlight back into space rather than it being absorbed on Earth. That's clouds in the stratosphere.
Yeah. I never once...
So it's the range of things.
The range of things. Obviously, with these kind of things, though, there's the practicality, the idea, and then the practicality of it.
Yeah.
If you could pick one thing right now that you could implement straight away out of all those ideas, what would it be?
Well, the one that is being implemented, and there's one that's in the news at the moment, which is looking at altering the stratosphere, putting aerosols into the stratosphere, which, again, we did it by accident when we were burning fossil fuels. There were a load of aerosols going into the stratosphere, and that was causing a global cooling effect. At the same thing with aircraft burning fuels. And as we've moved towards cleaner technology, we've been seeing higher global warming because those aerosols have been removed.
Right.
Which is rather an inverse of what we were trying to do by having the cleaner technology.
Yeah.
But, of course, the long-term effects of the cleaner technology reverses that. But this approach in the UK that's been announced recently is trying to experimenting with injecting aerosols into the atmosphere and trying to then get that global cooling via that effect. The other one that has been relatively popular is the iron fertilization in the oceans, where you put the dissolved iron in, it causes plankton to bloom, and then that plankton dies and falls to the base of the ocean, taking the carbon that is embodied in the plankton down into deep storage at the base of the ocean. So those are the ones that are really quite active at the moment in terms of research.
How's that measured? So, like, on a size scale for the iron into the ocean, what kind of scale are you talking? Are you you see the ocean. Is it someone standing on a beach and pouring it, or are you going in with oil tankers and doing this, or what's the scale?
One of the larger ones was a ship that left from South Africa into the Southern Ocean and then spread iron across the ocean. It was, I don't know whether I've got the number, but I believe it was in the millions of tons that was going in. It was a huge amount. And then that then leads to the what is the environmental impact of that? And I believe in that case, they monitored for an amount of time to see what happened, but not to the extent that you would see the environmental damage that might occur over the even longer period of time.
Sure.
So that's the one of the challenges with these things. Like, are you able to see all of the unintended consequences alongside the intended?
And with that, for example, then, with the iron one, is it ticked off the box to go, we tried it, it worked, it didn't work? Or is it, well, let's go again in a different ocean and we do twice as much? Or is it like, what was the...
It's still a case of research. So that last one, they got their phytoplankton bloom, but then there was a zooplankton bloom which ate much of the phytoplankton. And I believe they think about 10 to 20% actually did sink to the base of the ocean, which is not much.
Right.
The zooplankton then was eaten by fish, which were then caught and ended up on people's plates around the world. So the carbon then goes back to the atmosphere.
Right.
So you do not get the carbon going to the base of the ocean that you want and the volume that you wanted from that.
Okay. But so then do they deem that as a failure or success?
A need for more research, as most scientists would say.
And here we can help.
Yeah, exactly. Sim, can you help us understand how the current climate model works? So what kind of tools and data do scientists rely on to simulate future climate scenarios?
Well, the climate models are becoming very complex. So they have got some basic elements to them. And the first one, the obvious one, is the atmosphere. And that is looking at atmospheric physics, how the atmosphere behaves and how it changes with time. It also has the cryosphere, as at the moment we're getting melting ice, and that's quite important. In addition to that, there's some exchange in carbon dioxide between the atmosphere and the oceans. And so now climate models have incorporated the oceans into part of the model. We've also got the land surface, and then any other biogeochemical cycles, which is the most recent thing to have been added in. So the climate models try and incorporate all of these elements, and then over time they make observations and they say, well, this is what the model predicted. There's this difference. What is causing that difference?
Okay.
And one of the more recent ones was the reflectance of clouds, which has been now added into the more recent models.
Yeah.
Like, how do clouds affect climate? And it was a difficult one because it wasn't just about the number of clouds or proportion of clouds. It's where they are in the atmosphere that makes that difference.
Yeah.
So they become more and more complicated, these models, and they have been changing over time. Like early on, I would say the early models will be 1950s, although you can go back to physics, and there were papers back in the early 1900s, like 1900 to 1910, which were talking about how having large amounts of carbon dioxide in the atmosphere would cause heating. And that's just looking at the absorbance spectrum of carbon dioxide and saying, we have more of this, we've got more energy stored.
Yeah.
So that was very basic and 130-ish years ago. Now, the coupling between ocean and atmosphere, that only happened 1980s to 1990s. The aerosols, that was 2000 to 2010. Those were incorporated. And then the more recent ones is getting the whole Earth models and trying to couple all of these elements together
Yeah.
to create a full understanding of how climate behaves.
And then obviously in these like scenarios, then do you also have to couple into the natural change of the Earth? Is that mixed in with,
Yeah, that's been one of the biggest arguments that has gone on. Like, is the climate change that we're observing human-caused or natural? And it's definitely human-caused now. The most recent IPCC report, the AR6 report, and we're at 99.9% certainty that this
Really?
is human-caused. The natural forces are for a cooling effect right now, and a very slow effect, because natural causes are very slow in their
Yeah.
effect, whereas we're getting very rapid heating in comparison to geological scales, like much more rapid than anything we observe in any of the ice cores or any of the historic indicators like oxygen isotopes for temperature in the history of Earth.
And I was just thinking then, when, or can you tell, was the most, I presume because of technology, but when was the most damage done? Is it the most damage has been done today, or was it done in the 80s or the 90s when we weren't sure? Or is it just been a combination of everything? Or is it a case of, well, we knew what was going on and we still know what's going on, but it's not our issue yet?
It's a rather interesting question, because damage may not have happened yet. In that, and we're not at equilibrium.
Right.
So you could say that right now we are emitting more carbon dioxide this year than we've emitted in any other year, in which case there's more damage being done now if carbon dioxide is the cause. Or you could say that there are certain tipping points where if we reach that point, then, for example, you lose the Greenland ice caps. That would be one of the big ones that's coming up. And that's, if you take, for example, a mountain has got snow on the top, and that is a permanent storage of ice. But what if the mountain is made of ice? The mountain with snow on the top, you keep getting rainfall, it keeps freezing because it's at that height.
Yeah.
If you melt the mountain because it's made of snow, like the Greenland ice caps, you can't rebuild that mountain by having it being high so you get more ice on the top.
Right.
Like it's permanently gone.
Yeah.
So that then creates these things that are almost irreversible. It would be really difficult to go back when they happen. And if Greenland ice cap does melt or does reach the tipping point where it melts, it's storing about 6 meters of sea level rise for around the Earth. So an issue with that is equilibrium. We know that ice exists in water here, even though it's hot. Eventually it melts. But if that ice is like really big, how long does it take to melt?
Yeah.
Like we're not at the equilibrium of Greenland. If we maintain the temperatures we've got today, maybe we'll get to that equilibrium in a few decades.
Right.
So where the tipping point is, where Greenland will melt, have we passed it? Is it coming up? And there's a range of expectations for that. And as the ice starts to melt, you're also losing the reflectance. So white reflects lots of sunlight. So that equilibrium continues to shift. Even if we stop emitting carbon dioxide today, the equilibrium continues to shift because we are melting ice.
Interesting. So that goes on to this question then. So obviously with these scenarios, geoengineering, obviously it sounds very promising, but obviously it comes with a bit of controversy, I assume. So from your side, what would be the key risks and uncertainties that researchers and policymakers are concerned about with geoengineering?
The issue here is we're trying to solve the issue of emission of carbon dioxide in the burning of fossil fuels, which is causing this global warming, through not stopping burning those fossil fuels, but doing a scientific or engineering intervention in order to mitigate the issues that are caused by that. So we're not dealing with the cause directly.
Right.
So that's one of the things that makes the scientists and engineers think, should we really be doing this? This should be more of a moral or a political, let's deal with fossil fuels, rather than a science and engineering, let's try and solve this in a different way.
Yeah.
And the other issue is, what if we've got it wrong? Like, what if we cause harm through an experimental procedure on a global scale and ruin the environment a little bit? There are many cases where we have produced something or done something that we thought was good, and it turned out to not be good.
Have you got an example? For example?
Asbestos. It was amazing material, incredible insulator, and then led on to, because it's a crystalline material which has got long fibers, as it breaks down, you breathe it in and it causes cancer and all sorts of asbestosis. It is a material that we installed and then had to slowly remove, and old buildings still have a legacy of they find this asbestos.
Right, yeah.
And have to seal it off and make sure that no one can breathe it in as it starts to degrade.
Right.
So when we do a scientific intervention at a large scale where we don't really know what's going to happen because we've got no way to experiment, it causes some issues. We're very good at observation in science. We're not particularly good at prediction.
Interesting. Well, Mostafa, that will lead on to you then. Now, for those who are hearing about the first time, and I suppose people have heard about it in the news, how would you describe quantum computing? It sounds so. You know, when you say quantum computing, it sounds so science fiction. So,
Yes.
how would you, in your term?
Actually, it's very important because also engineers, a lot of engineers, they're still confused and they thought that quantum computing is something similar for what we're doing now with the traditional computers. So first of all, quantum computer is totally different because it's based in physics. It's based on something called the quantum physics, which mean that the elements can be something and the opposite at the same time. And it's giving many variables and many possibilities for the same thing at one time. And that's why it will take us first to understand, okay, what is the traditional computers that we have? So now all the time we depend on the binary business. So this is related to the language that we use it with computers. So the binary is like electricity. You have on and off, 0 or 1. And we call this bits. So the bit can be 0, can be 1, and that's it.
Simple.
Very simple. This is a current one. However, as well, we cannot jump to the quantum computing before we speak about the AI, the artificial, which is the revolution now in the IT, where it's based on something traditional computers based on CPUs, and then the AI is based now on the GPU, the graphic process unit, but it's still using the same way, which is the binary 0 and 1.
Yeah.
Quantum computing is used something called qubits. The qubits is totally different. It can be 0, it can be 1, and it can be 0 at the same time. And it can be any variables between the 0 and 1. So you can imagine that you make, when you're making this coin, you just flip it there. So you have head or tail. And it's only one answer. For qubits, it can be hidden trail at the same time, and it can be any point that this rotate in the air. So this is how more powerful this new technology is there, and how it can help as well to provide and help in complex things because it will predict many answers for one question. So these qubits there we called have two features, main features. The first one, what I mentioned, is called the superpositioning. It can be in different position and it can give you many variety in one time in a position. Second thing, which is more important, is called the entanglement, which if you have a qubit in a place and another one very far, like one in UAE and then one in USA,
Right.
and these two, they are entanglement together and affecting each other without any internet, without any connections at the same time. So when you're changing something there, it can be changing here very fast in seconds. And why this is too different? Because it's totally different that we're doing in traditional. And it's totally different from the answers that you can have, from the way they process. The GPUs, the CPUs, they can process in weeks, in months, in years, but one qubit can provide you the answer in seconds. So this is mainly to just compare it. I want to give an example so this it will be more simple to the
Yeah,
people.
please. Yeah.
So imagine yourself in front of a maze, a big one,
Okay.
and this maze have 1,000 of passes. And the normal thing in the CPU, what you use now in your iPhone, in your phone, the normal phone, or the on your computer, the CPU, one person have to go only one way, go to the end, and then come back and say, it was the wrong way. Let's try not the route number 2 from the southern way.
And that'd be like a 0, for example.
Exactly. It will go there, 0 or 1. So then he come back and say, this is wrong. You have to go to another way for the maze. The GPU, which is the AI, now it will make a parallel like 1,000 people, and all of them will start to go, and each one go to a different path, and then it will take time. So then he will come back and say, there is another, this path is right. So this is the concept of GPU or the AI. Quantum computing is like a drone. It will fly up, see all the buses, all of them one time, and providing you this is the direct path. Or maybe there is different buses, like 3 or 4. This is the right 3 passes that you should take, predict and simulate. So this is just to understand the concept of how different of quantum computing from what we have now at the moment.
But would you describe it then? Is that basically, are we talking Stone Age and Industrial Revolution? Like, what's the gap between?
Very high. That's because we're speaking about a totally different method of building it. So we're speaking, yes, exactly. It's like very far away from speed, very far away from solving complicated things. So it's totally different. A new era, new evaluation. So a new things that's required new elements, that required new applications, new software.
Yeah.
It's totally different. Totally different.
We were talking about this before, like, I think I asked you earlier on, you were saying like a year ago, you would have said this technology is 10, 15 years away. And now it's here.
Yeah.
My question is, are we ready for it? Do we know what to do with it? Like, it seems like everyone's kind of, when I hear about it on the news, it's like we've been caught off guard.
Yeah.
It's like, oh, all of a sudden we have this super technology, and people are like, we don't know what to do with it, or do we know what to do with it?
Yeah. Actually, it's not that easy to build it. So from concept perspective, yeah, we understand that it's based in qubits, but it's not that easy to build the quantum computing. It's not that rich people decided, I want to build the quantum computing. Yeah, this is a place. Let's put a data center like the normal that one that we do it for CPU and GPU. It's totally different. Why? Because this qubits to be able to work, it's need three main things. The first thing, it's the ultra cold environment. That's mean it's have to be near to the absolute zero.
Okay.
So you're speaking about a freezer, like something very, very cold.
Like space.
Exactly.
Space has been, yeah.
Yeah. So it's have to be near to the zero. And the equipment, if you put your phone now or your laptop in the freezer, it will not work because the component itself, it have to be designed to be able to work in this type of environment. So
Yeah.
this is number one. And the power, that's you have to keep the condition there to zero all the time, 24/7, without stopping. There is a power there. You already have a power problem with the AI now, because
Oh,
the
really?
software, for sure, the small GPU, the new one GPUs now is like 11 kilowatt. So imagine only one GPU, and you need thousand, and you need millions to be able to process for the large language model. So you already have a power problem. And in the other one, the qubits, we mentioned the ultra cold. This is one. Second, and it's very important, it's have to live to be able to work and provide you answers. It's have to live in a free noise, which means zero noise. Small vibration will not make the qubits work, and it will not be able to provide you the answers that you want. And this is another limitation that to be able to build this one.
When you say zero noise,
Yeah.
why? What, like, is it zero noise as in the human ear? Is it the zero noise on a cosmic scale, or what are we talking about?
Everything. So it's zero noise. That's mean the qubits is, let's say it's like electron in a microwave or a photon. So this is how the cycle of it. This one to be able to work, that's mean any small vibration, this one will not be able to run. So I'm telling you, a small vibration like what? Like sound. Now that when you go to the computer, you hear the sound of the fan, or you go to the data center, there is a sound already for the air condition. So I'm telling you, these elements, when you're speaking, that's mean you build a shields of microwaves for this to be able to work and reach to zero. So I'm telling you, the cost to build this is very, very high. It's returning us to how I can build it. You can, but the specific people, and it's not easy for all the people to do.
Yeah.
However, which is announced now, the giant firms like Microsoft and Amazon and Google, and one of them is Microsoft, they announce a chip, and they claim as well that this is the first chip for quantum computing that is provide qubit, and they called it Majorana, or Marona was Italian because it's named for the physicist Italian Ito Marona, which it will be in 1930 to 1937. This was the first case. That's why if you ask me last year, I will tell you after 5 years. But now, and the same thing as well, the same fault, it's mentioned by the NVIDIA CEO. Mentioned 7 months back, no, you will not find it in the market in the coming 10 to 15 years.
Yeah.
Last 2 months, is just in the NVIDIA summit, he mentioned, I'm sorry, actually, I was not expecting that the quantum computing will be in the business, and it will become coming to the market in the coming 1 year or 2 years. So this is the same thing coming from a high-tech innovations company like this.
What are the chances of them both coming out in a few months? Are they doing it because, is NVIDIA saying it because of Microsoft, or Microsoft know that they were going to release it? Like, how come they're all seem to be releasing at the same time?
I think because he's mainly field for the GPU and the concept of AI, so he thought from material perspective because quantum computing you need superconductors, which is rare to build it.
Yeah.
And he think that he will not be able from physics perspective, the current technology cannot build one. But when he see Microsoft and other giants showed him a chip and showed him a use case that it can help them, so he's saying it's totally different.
Wow.
He was not be able to do this.
Yeah.
So that's why he thought that it will not be in the market. But now, after the announcement happened, so he's saying, no, actually it is there. And he cannot build, by the way. That's why he only trying to do this from the platform and software, because he cannot go back and manufacturing the quantum computing. And Microsoft, they make the dream coming true. And in the coming years, it will be able to be in the market. For now, you can get it, not at you, the research, the engineers, the science through the cloud, because Microsoft have Azure cloud. So now there is something called Azure Quantum Platform where you can use it and you can test it and you can try it. And the AI is still there because AI will help the quantum computing to be able to reach to the questions, the answers, and the search that you want to obtain.
I feel like I'm a caveman. The more I hear about this, I find it fascinating, but I'm just like,
Not only you, trust me.
so with quantum computing is often called the game changer. From your side, could you share an example where it might open up new possibilities for, especially in climate and different fields like climate change, that kind of stuff?
For sure, I think Dr. Steve mentioned something very important about the element in the geoengineering. And this element for us as technology, as from engineering perspective, when you're building a technology, it's called parameters, it's variables. And in geoengineering and the climate sciences as well, they have a lot of parameters or a lot of system. The oceans, the water, the oxygen, the forest, the trees, the human behavior, which for me the most complicated thing is the human behavior. So quantum computing will give this capability to the science that he can see all of them at one, and he can predict each element of them. What if I change this in equation? It will affect what? So he will see the full picture. So then he will be able to predict, and the accuracy of predict it will be very very enhanced. And this it will give a lot of capability there. So example of it for me, the climate science now is like a old TV, black and white only. The quantum computing will make it a full colored HD and ultra as well, that it give them make the picture more clear for them so they can decide, yes, this is what I can change, and if I change it, this is the effect of it. And as well, Dr. Steve mentioned before they make a change, and this change affect other elements like the human or like the food or like the plants. With quantum computing, he can predict if this will affect in the wrong way or not, and it can simulate as well, so that he can run the test because he run it in the real life. And this is the new capabilities that it will provide for him.
So whereas before, we were talking about like you'd have to take in different scenarios of humans and climate change and different locations. The quantum computing will be able to do it instantaneously for everything automatically.
Immediately with the help of AI, because still you need the AI, because again the parallel processing, all of this element, it's need a large amount of data. Like if I'm trying to explain you to someone, I need to explain parameters. This is how his hair look, this is how his eyes, this is how his hand, he's tall or not, how old are you, how he was wearing, and so on. So I call this all parameters.
Right.
So AI will handle the large language model, he will handle all the large data, he will analyze it, and then he will be able to provide to the quantum computing everything analyzed. So then the quantum computing will help only on the equation that AI cannot help with, because still you can use the AI. So I really believe, yeah, quantum computing will it change the game for him, will make the view moving from a 2D view to 3 and 4D. So he see everything one time and it will act immediately because it provide you in seconds,
That's
It's
fascinating.
not weeks or months or years.
And then, will that, with that information, then do you constantly have to keep putting in different information daily, so the simulation might change? Like, for example, I don't know, say there's like a massive natural disaster.
Yeah.
Would you have to then add that in to change the computation? Or would it just be one fixed answer?
For sure, not only daily. It will be in a life parameters. So you remember when I mentioned something, the AI is providing this for the large data. So it will be life taking the information immediately. So any change in this information, going back to the qubits features, which is the integrament, that any change in any qubit, it will change the whole cycle. So it will change immediately the answer and the prediction, because the prediction, I'm telling you, a night it will rain.
Yeah.
In quantum computing, it will tell you in seconds when it rains and when it'll stop raining and when it can rain again after a year. So yes, for sure, the information it needed immediately. And what will help the quantum computing is AI, the GPUs, the artificial intelligence processing. So yes, you are to. It's not weekly or daily.
No,
It
it's
is. It's immediate.
It's almost mind-boggling, though. It almost seems like it sounds science fiction.
Yeah.
It's kind of like you wouldn't actually think this is possible, but if it is possible, then it's unbelievable in the excitement. It must be literally a game changer in every field: medicine, education, science. It must be like, who gets it first? Who's first in line, do you think, to get it?
I think the scientific first. Again, who owned the technology? We're speaking now like Microsoft. Now they announced the Majorana chip, and they announced this through the cloud. That's mean they mentioned the priority. It will go to science. We need to go to the medical field. They will go to the geoengineering as well, because this will enhance the overall world, enhance the life perspective, enhance the way how we eat, enhance the way of the medicine that we should use, enhance the disease that we didn't find a cure till now. This they need to find a cure so we live a better life. So this is for me the priority, and that's why they didn't give it to the business. Now they give it to the physicists, to the science, to the medical part as well. They give it to a research environment, to the people that they doing research to enhance the timing, the places, the way of living. So this is a priority for the time being. But that's not mean it will not come as well to the specific business. So it can touch the business of a stock, can touch another business of gaming. It's a change. It's something will touch all the elements of the life. Again, like what AI is doing, the same journey that we was speaking about AI 5 years back, and now it will go to the same loop, and it will take care of anything. It will be embedded in everywhere, enhancing for sure. Because if it's put in the wrong hand, that's mean it will be a disaster. So that's why the regulation that they already put it there. So yes, you are totally right. It will touch all the field. It's not only the geoengineering, actually. It's more and more.
Amazing. Dr. Stephen, from your perspective, how important is it to have a better, faster, more detailed, more every possibility simulation when it comes to geoengineering?
Okay, so let's say we're now in a world where the political approach has failed and that we are seeing some major effects of climatic changes, and that we need to then make an engineering or scientific intervention, like a country decides that they need to do something to try and change the world for the better. We have already said that there is a potential for environmental harm from this because we don't know. That's the big thing, we don't know. So if we're able to model all the scenarios, everything about this and how it will alter the climate, if we're able to create a better model than the current, the AR6 one that the IPCC has created, get to a really granular scale and start looking at ecosystems and start looking at as many interactions as we can, and then add into it, we're going to make this change, what happens? If you can get a solution from that, or a range of solutions from that using quantum computing, because we're able to do all of this modeling, then it means that that intervention, even though you don't want to do it, it becomes safer. And that would then mean that the scientists, the engineers, even with reluctance, they would have the confidence to do this if they had to.
Right.
It also means that if you do make an intervention, you can observe and say, we're seeing this, we predicted this, there's a difference, let's run the model again. Try and work out why there's a difference, try and work out how we can change the intervention, and do that in, from what I understand, real time. So then, instead of waiting for a month, a few months for a model to run and say, oh, something's gone wrong, you know now, oh, there's something that's gone wrong. You can then change that intervention or do an additional intervention to try and get back on track to what you were aiming for.
Yeah.
So again, it builds confidence and it builds accuracy in the way that we're carrying out this geoengineering. And again, I say, we really don't want to get to the point where we're doing this.
Yeah.
But if we have to, then we want to do it as well as we can.
Do many people push back against geoengineering? Is there much? Is there more for or against it in the sense of, or is because the unknown makes people go, oh, I'm not too sure. Whereas if quantum computing came in and said, listen, this is what the quantum computing is saying, it's not other doctors or specialists. Would that get more people on board, or?
At the moment, it's purely experimental.
Yeah.
So, I don't know. I think those that are saying that we should continue to put carbon dioxide into the atmosphere are more on the side of climate change is not happening.
Right.
Like denying the observation.
Yeah.
Rather than let's do geoengineering approach to solve this. I believe I would see it as a final option rather than the preferred option in most cases. Mainly because, let's say that we use the approach of putting aerosols into the atmosphere, or we brighten clouds in order to reflect sunlight. That's not something that is maintained without human intervention. So in order to keep the planet cool, you are continually sending flights up, continually putting this chemical into the atmosphere to make sure the clouds remain bright. As soon as you stop, you get a sudden rise in temperature for all of that carbon dioxide that you've been balancing out with this changing the reflectance.
Yeah.
And that's the same with most geoengineering approaches. I think the enhanced weathering or carbon dioxide removal, you are actually taking carbon dioxide that you've emitted with fossil fuels and trying to put it somewhere else. Most places that you can put it have a limited storage. So for most of the models that we look at, we say, let's use that storage for the things that are going to be urgent in the future, like important in the future, like the things that we really have no other option than emitting this carbon dioxide. So let's try and take some to balance that and store it somewhere.
Yeah.
We wouldn't want to use up the volume of storage space that we've got for frivolous things.
Right.
Just maintaining life as it is for a few more years until we get to the point where we've really got to do something else.
Yeah. Mostafa, back to yourself. With quantum computers are said to be powerful at understanding complex systems, like their climate, but with all its feedback loops and uncertainties, why is this such an exciting opportunity for science and innovation?
I think it will provide them four main things. So the error correction. So once you have a method for the error correction, I think it was one of the challenges that he mentioned that why they are doing any change. Maybe there is a small error in a specific things that affect the whole cycle. I think the quantum computing will remove this because the accuracy of prediction, it will be better for them. So then it will reduce. This is first. The scalability. So the scale of the business. I'm telling you now the power of a small qubit. So imagine the scalability in the future, which is it will be the coming months and years when you have millions of this. So how powerful and how more of unsolved equations that the science have, they will be able to solve it, and actually they will be able to solve it and enhance the way of using it. So this is second part. And then the third part is to see everything at once and to be able to control all the elements. So this is what excited me about how they change. We will be a tool for them. So imagine that you go to a doctor for your bones. So the first time the doctor will touch you and say, here it's hurt or not. So this is the first thing. And then you will not be able to understand what is there. He will tell you, go and do an X-ray. He need to see the bones. So he see better. Now he sees something inside that he cannot see with his eyes. He cannot cut you to see your bones.
Yeah.
So the X-ray will show the bones. And if he didn't find an answer, he do and say, you know what, I need an MRI. So then I can see it's better. For me, the quantum computing will provide this vision to the science and to the geoengineering, especially for what they're doing. So then they can deal it with it better, can make the right action in the right time before disaster happen. And this is very, very important. We're not speaking about small topic like cloud seeding as an example. If you feed it with the wrong materials, so that's mean the rain will affect the plants, would affect the flowers, which it will affect the food, which it will affect the human, which it will affect the act. So this is, I called it the full vision that we provide. Plus, what we are using now from the artificial intelligence, which is the third moment that you will use this with the AI. So that's mean you are a Marvel fan. Did you see? Did you watch Marvel?
I
fan?
do. Yeah.
So imagine that you have the technology of Iron Man, where he used the artificial intelligence to build the technology, and you add this to the capabilities of Doctor Strange, where he speak about the quantum things and he speak about the predictions and the simulation of things. So imagine these two powers,
Yeah.
which you will have it now, to provide for them the tool, the right tool to the science. So what will be the results? It will be huge. It will be fast, more accurate. So the benefit it will be for humans. So this is how I can see the four layers of the things that we can provide to the science at the time being.
But I'm just thinking, surely then it's maybe I'm thinking too simplistic. It's not endless. Then the AI will get more powerful, and then the AI will make the quantum computer more powerful, and then that'll make the AI more I suppose, is there a roof or no roof?
There is no roof.
There's no roof.
There is no roof. Actually, in all the technology we're saying, all the time being as engineers, we're facing an issue. We face it for the last 20 years. We have softwares, very, very powerful, but hardware is not power. Starting from the hard drive, when the speed of the hard drive, the mechanical one is starting from 7.5, and then we find something 10,000 RPM, which is per minute. And then we find that the maximum for hardware is 15,000. And then when we say that the software need more power, we go away from the mechanical, and then we use the flash. So this was something, I will move from the mechanical. Why? Because the software that we have, the hardware have a limitation to run it. So now we're finding a solution for hardware, which is coming the GPUs. It's solving something from hardware to process more, to go parallel. And with the quantum computing, I believe that the hardware will equal to the software for the first time. So if you're telling me there is end, no. And this is the normal thing in life. Science and technology is evolving, and every year and every time you find something better. Every year you find questions that you didn't solve, but now you have a solution. So then you face another challenge that you want the new generation to solve. So yeah, for sure it will not be an end.
But would this not be, though, before we kind of had, since the dawn of time, we had a situation, and we had to stop, think, work it out, and we either had A, B, C, and then we'd test A, B, C, and da. But now it feels with this solution, it's instantaneous. So once this is up and running, what else is there to answer? Like, in, say, in 5 years' time, we have quantum computers.
Yeah.
If we have all the diseases cured, if we have all the geoengineering possibilities, we have all the scenarios, then what? What are the questions?
In this time, there will be a new diseases that quantum computing will solve, because he will solve issues.
Yeah.
But there is issues that there is other questions that he will not be capable to do. And this is, I called it the normal track of life. He will answer questions, but he will not answer all the questions that it will be a challenge in this time. So after 5 years, from disease perspective, as an example, there will be a new disease. that we don't know, or we didn't know that this disease will happen.
Right.
So again, you need another things to be involved. So I see it normal. I see it. He will not answer all the questions. He will enhance, and he will solve the challenge that we cannot solve it with what we have current there.
Right.
The same thing for the X-ray. Before the X-ray, how we was doing this? They having the manual ways,
Yeah.
and the X-ray only solved these issues. But we find maybe the problem not in the bones; it's near to the nerves. So we need to see the nerve, and we need to see the psyche. So then we invented the MRI tools, and then we need to see more. So that's why again, I really believe that the technology it's endless. But every time they have their own challenge, but we don't understand it now
Yeah.
because it will be a new generation, new people using it, new difficult things, like new different things. I'm sorry, from technology perspective and from human being. What's the question that we'll have? Because it would totally different. Your phone it will not be the same. Your computer will not be the same. The TV, the way that your car will not be the same. I believe it will be an augmented between human and I called it the artificial intelligence or the quantum. So you will have features in you. It will be different. That you will embed the chip in your body. I think it will be normal. So I really believe that this is the rule of life. Every time you have challenges, and then you invent something that it helped this challenge, but it build another things. And the same thing for geoengineering. If you ask him, do you have the tools that you're using now? It's like the tools that they're using in 20 years. He will say no. Am I right, Dr. Steve?
20 years ago,
Exactly. It
things
was
have
totally
improved.
different. And now you have challenges. Am I right? So let's say the quantum computing will solve. So we will face another thing. We will know things that we didn't know before. Like you look to the stars long back. Did you understand that this is a star? But when you understand, you'll find another challenge. How I can travel there.
Yeah.
So then you invent more. This is how I see it in loops.
Dr. Stephen, 10 or 20 years down the line, what's your outlook on geoengineering, especially if we continue developing more advanced model tools like the quantum computing, like the way it seems to be going leaps and bounds? Like, from your side, what was it like 20 years ago to today? And with the technology that's coming in, how do you think it will be like in 10 or 20 years?
I think 10 to 20 years down the line, we'll know whether we need to use it or not.
Okay.
Because at that point, we will have gone past either gone past the peaks in fossil fuel consumption, and so carbon emissions will be declining year on year. They say that we're close to the peak, but we've been saying that for the last 5 or 10 years, and carbon dioxide emissions keep going up. If we go past our budget on carbon emissions, then we know we need to do some sort of intervention in order to row back. So we will be past 1.5 degrees. We then need to somehow get back to 1.5 degrees after we have hopefully ceased emitting fossil fuels.
Do we know that now, though? Is that
the models that are released by the IPCC, the carbon dioxide reduction curves have gone from lines like that to more and more steep lines of we need to reduce more rapidly than we would have needed to if we'd started doing that 20 years ago.
right?
But
And who would be
we're not past the point of we need to then use technology to get us back to something that's safe.
what would be the instigator? Are we looking at like America or China or India? Are these the main guys who, or European, like for carbon emissions, like to get these down? Or is it like if America turned around tomorrow and said, we'll do it, could they do it alone, or is it a global problem?
No, it's a global problem.
Global, yeah.
Yeah, you really do need everyone working together for it. Let's say that it was just me and I'm trying to make myself as sustainable as possible.
Yeah.
And I put solar panels on my roof, or perhaps even I give up on technology and go and live in a forest and just burn twigs that have fallen to the ground. Then my neighbor next door gets their wood burner, goes into the forest, chops down a load of trees, and like not a sustainable wood source,
Yeah.
or does nothing. Then you do not have the overall effect. You do not have the overall result.
Yeah.
It is the whole world working together that gets us there, which is why it is the United Nations that has been leading this, and why the withdrawal of the US from the Paris Agreement is particularly problematic, because that then breaks that international agreement, international working together that we've had on this for so long. Even with the success of the UAE consensus and that final statement of let's actually reduce all fossil fuels. So recently, we finally said, let's reduce all fossil fuels. That hadn't been said any time before COP28. And that was an amazing point where the whole world was working together at that. And it really took a lot of effort within the UAE to reach that point. And then we see in future years, like, how is that going to be kept up? How are we going to keep working together as a global community in order to achieve that when we start getting towards some of the more difficult things? Because right now, much of what we're doing is focusing on science and research to try and get things cheaper than the fossil fuel alternatives. We've been working with solar panel technology. It's now really cheap. And batteries are now getting incredibly cheap. And they are now to the point that the renewable energy options are cheaper than the fossil fuel alternatives, which is why they're starting to win. Why in the US, we've now gone past 50% of electricity generated by renewables, even in an atmosphere where they are saying, let's go with the fossil fuels, we want more of that. They still have more than 50% renewables because it's cheaper. The same thing for the electric vehicles. The electric vehicles have become cheaper because battery technology became cheaper. So as we focus on the scientific research and development, the technology development, we've been getting these technologies to the point where they are usable. And there are other technologies that are not there yet, like hydrogen technology, which is the one that we're looking at for being able to continue to fly and having large ships moving around the Earth with zero carbon emissions. We don't have that technology up and running yet, and maybe we won't by the time we need it. And then it starts getting to some difficult decisions, or decisions where you are affecting people's lives and affecting people's pockets individually.
Yeah.
Rather than what we've done to this point, which has not really had that level of effect. And here in the UAE, it's relatively, and the technologies that we need are reasonably available, apart from the hydrogen one, which is being developed. In colder climates, the move towards using heat pumps rather than using natural gas boilers is a really big societal change and a really problematic one. And we can't keep going with the natural gas boilers because you're emitting carbon at every household
Yeah.
that has it, and you can't capture that and then take it and store it. And it's not possible to avoid those emissions. So you either have to keep going with the natural gas boilers and then en masse somewhere recapture that carbon dioxide from the atmosphere at great expense, or you need to switch towards some sort of heat pump, or you need the hydrogen boiler, which has a load of technological issues to it. So going back to the original point, yes, we need everyone to work together, and yes, some bits are going to be difficult, mainly because of the time scale that we're working with. We've said 2050, some countries 2060, but we've set a target, and we need that, otherwise no progress will be made. But with that target, we have to work together.
Do you think that so what's that target? 25 years. Is it doable, or we go back to, say, 2000 when it was 50 years away? How are we doing on the timeline or scale, or is the world is changing and it's just inevitable that China will turn around and say, whoa, it's our turn now, you guys had your turn? Is India going, whoa, we're not, we're up and running? Is America kind of going, listen, we actually like it? Or is, is it all talk basically?
Well, this is the problem. It's not science and engineering, it's politics.
Yeah.
And politics is unpredictable. And that is what makes this very problematic to know whether we will require something from geoengineering or not. Because if you need every country to do the same thing, some countries are not going to make it.
Yeah.
At the moment, there are countries that are on target for 2050. There are some that are ahead of target, relatively few, and there are more that are behind their targets. If everyone met their targets, then we would make it by 2050 to net zero.
Right.
But not everyone is on target, and some are, as I mentioned, with the US withdrawing from the Paris Agreement, some are moving backwards.
Yeah. So that's what I'm saying. Then is it talk? Like, has China jumped on board? Have they said we're with you or against you? Or are they kind of just, I'm using China as an example because I just think, as we were talking about earlier on, they seem to be getting faster and bigger and quicker with everything. I can't imagine they want to stop.
China is an interesting case because they have some of the fastest pace of solar panels and electric vehicles sales anywhere in the world. They also have the largest number of coal-fired power plants that are left. There are not many countries that are still building coal power plants. In China, they are still being built, but that's mainly because the demand for energy is so high because of the pace of the development. And they're building more coal power plants. They're also building more renewable energy sources than anywhere else in the world. It's the volume of energy requirement that is driving both of those.
Right.
I think that China is going to stick to its plans and is going to reach net zero. And I think they have promised 2060 rather than 2050. I think they promised a peak of carbon relatively soon, I think by 2030. And so far, they are running to their predictions.
Because it's affecting them as well. So they need to, they need to move. Yeah.
So I think they will do it. They get a lot of bad press, but that's mostly from countries that are trying to justify not doing anything.
Well, that's what I was going to say. Is it a press game, right? Where it's always,
It's politics.
politics.
Yeah, this is science being pulled into politics, which is always an uncomfortable arena for a scientist.
Technology too as well.
Yeah.
Technology too. Like not all the people can have the technology. And sometimes, I don't know, I feel some of the regulation maybe need to change or need to be enhanced to be able to all of them working at the same image to improve the life for the, not for us, at least for the coming generations. I just have two quick comments because he mentioned two important things, and I really believe this is a part as well of how technology will support science. So he mentioned the things becoming be cheaper when he's speaking about the electricity cars. So it's not only cheaper and more powerful. So the battery that you're doing, it's taking like 300 or 500 kilometer per day for one battery. Imagine that it will be 2.5 million kilometers with one battery. So this how improve and the less use as well of recharging it. So it's coming soon because again, AI and quantum computing will make a new battery. They're just making for sure, and they're changing the way of power, the understanding of power. Till now, the power cannot go remotely. You cannot charge your phone while the power is here. You need to link it. I think the quantum computing will put other theories or other things to achieve the enhancement to improve the battery. So this is one, not only because of it cheaper, because it will be cheap, but it will be more powerful. So this is one. Second, when he said that you need all the players, you need all the worlds to support the concept of climate change or climate science, and this quantum computing exactly will do the entanglement that we mentioned, where the qubit is there or the change is there. There is a mountain ice is disappeared. So the other qubit that I have it in another country will modify itself and say I need to change this in mine because the effect happened in Ireland as an example. Or the smoke or the CO2, as an example, increase in a specific country. So my quantum computing, with the alignment that we do together, he will provide me the new prediction, a new simulation for what exactly the right thing that I should do. And this will help with the overall. So it will solve the current challenge.
So what you mean, for example, is say, because it'll be all instantaneous, if something happens in Tahiti,
Yeah.
then something in Ireland will be able to help it or counterbalance it
Immediately.
immediately.
This is what I'm saying, the entanglement and the new physics. It's a pure new physics. How come they will be entanglement and they are far? This is the power of it.
Yeah.
And this is what they prove. And to need to prove, you need use cases. When all the people was talking about artificial intelligence for the last 5 years, am I right? But no one feel it when ChatGPT come to the pictures, and then he helped me to write my emails, to give me a full business plan, to fix my finance, to tell me what is the stocks that I should buy. So it's become a use case.
I feel like ChatGPT, I feel that it's just become it's become everyday life. But I don't know, I don't remember when it did, but now it is. It just feels like when someone says it, you go, "Oh yeah, yeah. Did you get that from Chat?" Like, but I don't remember it. Kind of like it just kind of became.
I called it the use case. So the use case can show you, like, what's mean of use case? If I start to talk you about AI, a lot of things about artificial intelligence and how this it will change the world and robots will control us and so on. It's only talking. But when the chat GPT, it's become a surprise because when the people are starting to speak with it, they find a human language. And then they find there is a lot of hard tasks that he was doing before. As an example, as I mentioned, a lot of pictures or generating picture when it's specific. I need myself to be in Italy and carry a flag of Egypt in the pyramids. So
Yeah.
in seconds he will be able to create it. So it's front of my eyes. So then wow, the artificial intelligence is great. The first version of it, it's have a lot of hallucination, a lot of jailbreaking, a lot of data poisoning because I'm using and then I find that he answer in different tracks. This is not the right answer. So I say, no, it's stupid. But version 2 of ChatGPT or version 3 or version 4, he reduce the hallucination and he reduce the data poisoning and he makes something quicker and reasoning, like thinking exactly like human. And now the answers is better. The integration is better. He moved from the narrow AI to agentic, like he will support you as a company, as you have your secretary, you have your marketing manager, you have your finance manager, you have your driver, whatever that you can think, he help you with.
Yeah.
This is called the use case and called the Gen AI use case. Quantum computing, once Microsoft or Amazon or only people that they started to show it in market, he showed the use case for geoengineering, it will differentiate. It will show him like, this is a prediction, this is a simulation, do it in a small case. It changes this elements in water as an example. So this, it will be better. You can use the water on the sea and you can drink it, but you need to do 1, 2, 3, 4, 5. Can you imagine this? If you can use the water in the sea to drink it, how much it saves that I cannot. Just a small example. What we are waiting, a real use case for the science. So then it will be, we will talk about quantum computing, the same like AI for the kind time. So this is the two comments that just for what he mentioned.
I always think of like James Bond villains. And I remember you said earlier on, if it gets into the wrong hands.
Yeah.
What would be a wrong hand scenario with quantum computing?
So they need to use it in weapons. They need to. I will use example that geoengineering. If we said that if you change in a specific thing in this country, it will lead to disaster there.
Yeah.
It will lead to different type of rains. It will lead to more clouds. Changing the climate itself for this specific country. So it will be a disaster. But the good things for me, I see it. It's very difficult to be in the wrong hand in the beginning.
Yeah.
Because it's costly. It's dependent on a lot of science that we see who control the game. The people with a good face, the people with they wanted to improve. They put the regulation. It's not have to. It's not offered to all the people. So then it will come to the wrong hand, and he can do something with it. But yeah, we need to make sure that it will not go to the wrong hand, and this is very very important. Same challenge with the artificial intelligence that we're doing now. And now they start to do regulation, and no one can have a direct access to the GPU, or I can buy thousands of GPU and can build the use cases that he do. No, The same thing it will be in quantum computing.
Is it open technology? Like, is this? I think is OpenAI? Anyone can do it.
There is type of it, but in quantum computing, they didn't provide it as an
They haven't
open.
provided. So Microsoft and Amazon are the two. Like,
For sure, giving you the engine, understanding what you're doing, and then to support you over the cloud. You can. That's why I'm telling you, it's not that easy to build. You need the same science, or you need the people to build it again. And from cost perspective, we're not speaking about $1 million. We're speaking about billions of dollars have to be there to just showing small things.
but does this make Microsoft then a superpower?
Yeah.
Literally, it makes them a superpower.
If they make again the number, how many use cases that they can provide, and what exactly the support, this is what they need to prove it now.
Right.
But it's coming, because if they started, so that's when you move from a dream to reality. And once the reality, that's when people will copy and people will try. So it is coming, and I feel what we are waiting next, which part that it will solve,
Yeah.
how effective will it happen. And I think this is soon. Let's say if we do the same interview, maybe for next year or next, after 2 years, it will be a totally
I won't be
different
here. It'll be
discussion.
AI.
Maybe, yeah. Maybe.
Mustafa, this actually goes back to you, but I think you kind of answered. But I'll just ask again. Oh, so over the next decade, what are you most excited about? But also, what are the problems that comes with it?
Problem is will come with it. I will not be able to add a lot of values here, because I really see the solve, but I cannot I cannot penetrate or predict how it should be the problem that it will cause. I only can see if it's in the wrong hand, they will misuse it. So I don't have a direct answer here, but I have a direct answer of what it will change, or how the view it will be. In football or in soccer game, what we can see now, we just see the view from one player in the game. Once the quantum computer is there, you will see the full field, all the players' views, and the team that play against
Right.
you, and where the position of the goalkeeper. So you will be able to score goals. And this is very, very important. The view will be totally different, and the use will be totally different. But I think once we're starting to use, that challenge will come, and then I will be able to provide you more answer of the problem that we can do it. So this is how I see it.
Yeah.
Full vision, full view, simulation, prediction, fast. So this is what is missing now, and this is what it will has. But problems, once we use this, then we'll face more problems. I'm sure.
More money,
Because
more
this is
problems.
technology, yeah?
Yeah.
We'll face more problems, and it will be enhancement.
Yeah.
Version 1, version 2, version 3, the same sequence there.
Do you think in 100 years' time or 200 years' time, they will talk about now? Will they talk about 2000? Well, I'm not sure if it came out in 2024, 2025, but will this be talked about when they go?
We will be the stone. You remember when you just
No, but that's what I mean. Will that be the turning point in history? Will they go? That's when they broke quantum computing.
Exactly. This is, I feel it's exactly, it will be the time that they mention these people, they change the wallet. So yeah, we are lucky that we live in this, because I love technology. So when you're speaking about the training model and how you put the data and the information that we have now, and then you have the tools that it can analyze this information. So I think we are living in the right moment to see all of these miracle things.
Yeah.
Especially for science as well, that now they have tools and they can do the change without affecting other people, and it's very useful, and they will use it, so they will change everything.
Yeah.
So I think all the credit will go to them, and no credit will go to the other people.
And that was curiosity. If you could have quantum computing for 5 minutes, what would you do in regards to geoengineering? If you could type in one scenario or one question that you'd like to put into the computer for an answer.
For geoengineering, it would be trying to get the full model, but I think I'd need longer than 5 minutes to get all the information that I need to put in order to get an answer out. The processing is fast, but the input data, I'd need to gather all of that together. But yeah, I would say which of these options would be the best one to be using. Cheapest and no environmental consequences to implementing this.
Yeah. what would you? Because I think we talked about this area side, Mostafa. What would happen if we put in the information, but we didn't like the answer?
We wouldn't do it.
No, but it was a kind of a case of if, or maybe we can get around it. But the computer went, yeah, this is no problem. This is how you fix it, but it's going to cost you this. Do you think then we'd be like,
Then it becomes a political issue,
yeah,
rather than a scientific issue.
yeah,
And as long as we are still in a world where politicians like to be informed by science, then that will be a useful answer.
You will not face this with quantum. You are facing this with more on artificial intelligence, because who will deal with the data will be the artificial intelligence, not the quantum. Quantum will come only. It will be like this specific agent come to solve. You cannot solve this. I will solve it to you, and then he go back and keep the concept of GPUs and AI to solve it. So in AI, there is three main things, and I think this will answer you quickly. So you have the data that you are putting there, and you need to make sure the data is clean as much as you can and useful for the system. And then you have the training of the model itself that you're doing in artificial intelligence, and then the validation. So the validation, it will come if he give me the answer, not the quantum. Now the AI will give you the answer that you do not like. As an example, what is the best thing to the world? He told you, you know what, like Throne in the movie, like let's say, let's kill the half of the population, as
yeah.
an example. So the validation itself, who will give it to who? Who will give it to the people that don't have the control to kill all the people? So this is one. So to validate this, you need validated by human, and the human have the rules and rights and everything. So again, if it's in the wrong hands, it's a disaster. But what the proactive that I can see now in from technology, from physics, they trying to put the regulation. So when you don't like the answer, you cannot do it, because to do it, I need you to reduce the pollution by half. Let's say that we need to terminate the half of the pollution. What you need to do? So that's mean you need to create, let's say, something to affect the DNA. Can you do this? You cannot do. So the validation itself is saying, no, I need a better solutions, because I cannot have terminate the half of them. So then he will go and give you the right answers. This happened daily, by the way. You will face this with your ChatGPT or your Gemini. It's coming to reply to an email and telling him, this is the case. I'm fighting. I have a fight with my manager. And he will tell you, you know what? Reply to him and tell him that you are stupid. So for you, yeah, you can send this, but it will be very stupid to
Yeah.
like you will be fired, as an example. So you'll tell him, I'm sorry, I cannot reply. He is my manager. I need another way. So then he will provide different ways that you can suggest.
So keep asking the question.
Yes, prompting, and this is another science as well. And another, the prompting in AI, it's the main important things, because when you deal with AI and then when you deal with quantum computing, it's totally different. If you're dealing and do the prompting for geoengineering, you will ask specific questions. If I go to the prompting of Dr. Steve, it will be better than your prompting. He will get more answers, better answers, advance,
Because he knows the questions to ask.
and he understand that. That's why the humans being. So that's why we're saying that the AI or the quantum or whatever the new technology, it will make the stupid people look normal, and the normal people will look smarter, but the smarter people will be genius, and the genius will look good. So still he keeping this distant, and I call it the prompting. How you will ask, and what is the information that you have to ask, and how you can get the right answer that you need. And this is, I hope that it answers your question. If you get an answer that you don't like, you need to validate it, and you will not have the power to apply something very dangerous. You don't have it. Very simple.
So this final question for you both, or Steve, we'll go with yourself. So in one sentence, why are you optimistic about the future of climate solutions, whether through geoengineering, quantum computer, or both?
I'm optimistic.
Or are you? You don't have to be.
I think I am. And what I see is that we do make progress year by year, whether it is in the technological development or in people getting together and agreeing things during these COP events, which are becoming larger and larger. So I see progress each year, and perhaps not rapid progress all the time and in starts and jumps, but there are things happening. Every year it seems to get better.
Good. Mostafa?
I still count on the human nature, which they all the time trying to do the right things, to do the useful things. So if I have to say one sentence that is saying that quantum computing will open new doors and will provide more capabilities for the world to be better and for everything to be enhanced in the right way. So this is how I see it.
Brilliant. Gentlemen, thank you so much for your time and expertise.
Thank
I
you.
really appreciate it. I'm not sure where I fall in that category. I hope I'm going to be a smarter. Maybe a super genius. I'm not sure yet, but
You are.
fingers crossed. Thank you very much.
Thank you.
Thank you, guys.